All right, so we're just talking about Jupiter's atmosphere. Um, so with the belts and the white zones. So the they're alternating patterns on Jupiter. Actually, we'll find that Saturn has this as well, but not as pronounced in the visible part of the spectrum. We'll get to that later. But all right, so what is it that's causing these belts and zones, right? So remember, the zones are the whiter patterns. Oops, let's go back to this. The whiter patterns. The belts um, are the darker regions. All right, so what's going on is inside of Jupiter. Of course, there is this enormous heat, um, which is still there from the formation of such a gigantic planet, and that heat rises through because heat always travels from high temperature to low temperature, which of course would be at the surface, or sorry, not the surface. Yeah, it's hard. Sometimes you forget. Remember, it's just clouds that get thicker and thicker as you get towards the center. At any rate, the heat travels up in a convective manner, and of course, because the planet is rotating pretty rapidly, right? At the equator, it's spinning at roughly once every 10 hours or so. Um, at any rate, what happens is there's the Coriolis effect as well. When the hot gas rises, it gets deflected to the north and to the south, and yeah. All right. So anyhow, um, so the heat comes up, and then when it reaches the the top of the clouds, let's put it that way, the top of the clouds, the higher altitude gas radiates heat into space, and then as it cools off, what happens is that gas, because Jupiter is so massive, the gas doesn't go off into space. It'll sink back down into the planet, um, into this incredible atmosphere of the planet. All right. You get these zones and the belts. So with the belts, you actually see a little further into the planet. Not you're not seeing down into the heart of the planet. That's why we use gravitational information to determine what's going on inside the planet. But we can see the upper layers of the clouds. Oh, and just to let you know, I think it was 1995, um, the Galileo spacecraft, which orbited Jupiter for many many years and gave us um, some incredible information about Jupiter and Jupiter's moons, which we'll get to shortly. That Galileo spacecraft dropped a probe into the atmosphere of Jupiter, and the probe didn't it fell as it fell into the atmosphere. It gave us some information. I mean, it eventually it got as it fell into the atmosphere, it got crushed and no longer transmitted. But that gave us some information about the interior of Jupiter's atmosphere. All right, so this is just showing you what's happening with the Coriolis effect. You can have these alternating um, um, bands and zones. The zones are the light colored areas. The bands are these sometimes I say bands, but some books talk about bands. Some books to describe them as belts. It means the exact same thing. The darker regions, right? But what happens is, because of the Coriolis effect, because the planet is spinning, you get rotation in opposite directions. And actually, there's a video I'll try to link it onto Blackboard, so you can see the belts and the zones, spinning in opposite directions. All right, and one of the things that we measured the speed at which these zones and belts are moving, and they're moving rather rapidly. And by the way, they're not the fastest. It's not the fastest atmosphere, or the fastest winds in the entire solar system. Surprisingly, that's going to be Neptune, which we really never expected Neptune to have such high winds, but it does. Anyhow, so 300 kilometers per hour is pretty rapid. All right, so these this is what I was just talking about. The belts and zones, they alternate in the direction that they rotate because of the Coriolis effect. And what happens is they cause these massive cyclones, and one of them, of course, we know has been around for at least 300 years, perhaps even longer than that. And so this is it's a giant hurricane, basically. Of course, that's called the Great Red Spot. In recent times, it has gotten smaller. We don't think it's not a permanent feature of the atmosphere of Jupiter, but it rotates around with the planet. So it's just a gigantic storm, a gigantic hurricane on Jupiter. And again, it's been raging for about, and the other thing is, it's been raging for about 300 years. It's big enough you could literally put the Earth inside of this. It's that big. All right, so there's the Great Red Spot again. They're just showing you the pattern of the flow pattern. And sometimes you see these white spots right here that they will form as well. These are other hurricane type features, and they'll get swallowed up by the Great Red Spot, and then it spits them out as well. This is one of the poles of Jupiter as well, and of course that was one of the big missions of the Juno spacecraft, which as I mentioned before, is it depends on when you watch this, but right now it's currently the Juno spacecraft is currently orbiting Jupiter in a north-south orbit, to give us information about the poles and other information as well, of course. Jupiter has this incredibly strong magnetic field, because remember that there's the hydrogen turns metallic towards as you get further and further towards the center, and of course a metal conducts electricity, and the electricity that is moving around causes that's called the dynamo effect. That causes a very, very strong magnetic field around Jupiter, and in fact the magnetic field, as it says here, is roughly on average about 20,000 times the strength of the Earth's magnetic field. So we see lightning on Jupiter. We see auroras because remember, charged particles are coming from the sun, and Jupiter's incredible magnetic field will deflect those particles, and then when they hit when they hit the atmosphere, the upper atmosphere of Jupiter, that they the friction causes them to light up, and so we space different the Galileo spacecraft observed this, and of course so has Juno. Um, Jupiter, it was kind of in the 1950s, or even earlier than that, but around the 1950s, radio astronomy. So it's using telescopes. They're much larger telescopes, um, but they're using these telescopes in the radio region of the spectrum. Radio is much larger than visible light. Um, the waves, they still, radio waves travel at the same speed as visible light waves. Um, they have a much longer wavelength, and one of the things that came about in the 1950s was that Jupiter was emitting radio uh, noise, and people try to understand, why is it that Jupiter is a source of radio noise, and it has to do with this very strong magnetic field, and of course it's the trapped charged particles in the magnetic field. So this is actually showing some thunderstorms on Jupiter, or in the atmosphere of Jupiter. Um, All right, so let's see. The magnetic field, of course, just like the Earth's magnetic field, there is a region well above the planet's atmosphere, where the magnetic field traps charged particles, and they basically bounce back and forth, and that's very similar to the Earth's Van Allen belts. Um, all right, so this is you can't really see these lightning strikes from telescopes on Earth. You need a spacecraft that's in orbit around, well, a spacecraft that gets close enough to Jupiter to be able to take pictures of this. It turns out that all the Jovian planets, all the gas giants, have a ring systems, and we actually knew about the ring systems before we got before the Voyager missions. All right, so let me mention the Voyager missions, and I'll link a video on the Galileo spacecraft and the Juno spacecraft, and before both of those was the Voyager missions. So in 1977, NASA sent two spacecraft called Voyager 1 and Voyager 2. And the reason that they sent them out at that time is the planets, the outer planets, aligned in such a way that it wouldn't require extra fuel to send the Voyager Voyager 1 and 2 spacecraft to visit Jupiter, Saturn, Neptune, and Uranus and Neptune. And so we sent these two spacecraft out, launched in 1977. In 19, I think it was 80 or 81 is when the Voyagers first encountered Jupiter, and then they went on to Saturn, and one of them, Voyager 1, actually left the Saturn system and went in a direction perpendicular to the axis of the solar system. Um, it has to do with the large moon of Saturn, which we'll talk about a little bit later. All right, so the Voyager spacecraft were the first ones to investigate this, and they also detected the rings of Jupiter. The rings of Jupiter are made of other material. They're actually mostly dust particles, and they have to be replenished over time.